Hey, ladies and gentlemen, welcome to Coach Hanik's Introduction to Kinematics Review Sheet. Questions 1 through 5. First one says a woman walks 10 kilometers due east, and then 10 kilometers due south, and then decides to run 20 kilometers due west. And so I have my starting point right here. And my finish point is where the other arrow tip is. So I draw my line here for the resultant. And I want to calculate that. It says find the magnitude of the woman's resultant displacement. Well, if I draw a line down here, I know that that is also 10 kilometers. And that divides this line here. And this is 10 kilometers. So I have really a triangle of 10 and 10. And the question is, what is R? C squared equals A squared plus B squared gives me C squared equals 10 squared. I'm going to leave out units here for this. And 10 squared, which gives me an answer of around 14.1 kilometers. And since this said what is the magnitude here of the resultant, that's all I have to do. If it asked for direction, which I'm going to add to now in green, I would have to say general direction of southwest, because it would ask specifically for an angle if that was the case. All right, and that's number 1. Let's check out number 2. A car travels 100 meters south in 10 seconds. So I got 100 meters south, and that time, so distance was 100 meters, and that's south, or displacement I should say, and the distance is, time is 10 seconds. Well, if you think about it, it says the displacement of the car at the end of the 1 second interval is what? Well, what does this do? I know that in 1 second, the distance was 10 meters. That makes sense. So every second that the object traveled, because it was 10 seconds, it moved 10 meters south. So the displacement here would be 10 meters south. For the next question, the part B, or next B, this is what is the displacement of the car at the end of the 10 seconds? Well, at 10 seconds, I know that the distance was 100 meters. So I would say that the displacement is 100 meters south. And that's the answer for that one. Number 3, a baseball pitcher throws a fastball at 108 miles. V equals 108 miles per hour. If the batter is 18 meters from the pitcher, D equals 18 meters. Approximately how much time does it take for the ball to reach the batter? Okay, quickly I could say V equals D over T. And I could plug in 18 meters over unknown equals. Well, the challenge is I am not able to use miles per hour. I must convert that. So 108 miles per 1 hour. I'm going to do this really quickly here. So I have 1 hour over 3,600 seconds. That allows me to cross hour out. And so I'm left with seconds, which is, I'm going to put in meters per second so I can continue with the equation. And then I'm going to say that there is, in 1 mile, there is 5,280 feet. And then there are 3.3 feet for 1 meter. Looking at that, I have my miles cross off, my feet cross off. I'm left with meters. That gives me an answer of 48 meters per second. Plug in 48 meters per second. All this is going to go up here. T equals 18 meters over 48 meters per second, which the meters are going to cancel out. Time equals 0.375 seconds. If you haven't realized that, ladies and gentlemen, that is insanely fast. 108 miles per hour. The record was 108.1 miles per hour. I think It was Nolan Ryan, who actually set that record for a pitch. They had less than a fraction of a second. That's a blink to actually react to that ball traveling by them before they get to swing. That's crazy. Here we go. Number 4. A bird flies horizontally. A bird flying horizontally changes its speed from VI equals 15 meters per second to 5 meters per second in 2 seconds. What is the object's acceleration during the time interval? A equals delta V over T, which equals VF minus VI over T. A equals 5 meters per second minus 15 meters per second over 2 seconds. A equals negative 5 meters per second squared. This should make sense because we're changing from speed and going lower. Since we're decreasing or decelerating from 15 to 5, the object is slowing down. The negative represents the acceleration in the opposite direction. That's all the negative represents, is direction. And lastly, number 5, we're flying through this, beautiful here. An object initially at rest, VI equals 0 meters per second, accelerates uniformly at 3 meters per second squared until it attains a speed of VF equals 30 meters per second. What distance does the object move while accelerating? D equals unknown. I'm going to use VF squared equals VI squared plus 2AD. VF squared is 30. I'm going to leave out units here to make this a little easier because I have a small board. 0 squared is 0 plus 2. 3 unknown. So we have 900 divided by 6 equals D. D equals 150 meters. Hope you enjoyed it. Please comment, like this if you like the YouTube video, or comment, and I'll do my best to answer. Have a wonderful day.